Hello, this is Mr. Stansbury. I'm going to take you through the 3B notes on complements of sets. At the end of this, you should be able to understand what a universal set is and also what the complement of a set is. And then with that knowledge of universal set and complement of a set, use that to find unions and intersections of sets. Okay, so with that, let's take a look at some important parts of that. So let's start off with universal set. Okay, universal set is basically just all the possible elements that we're going to look at in a set, and that's represented by a U. And I put little what do you call those, feet? I can't remember what those are called, but I put those at the top here so that it wouldn't be confused with the union of a set. Okay, so I'll always try to put the feet up there to show that it's a universal set as opposed to the union. So I wish they would have used a different number, different letter, but you know, you get what you get. So with that, let's take a look at now what complementary sets are. So complementary sets, basically the easiest way to understand this is just take a look at a quick example, which would be if the universal set is U equals 1, 2, 3, 4, 5, 6, 7, and 8. And again, back to what universal set means is basically the only elements that we're going to look at for this example are 1, 2, 3, 4, 5, 6, 7, and 8. That's everything in the universe, so to speak, for this example. So if this is the universal set, and set A is 1, 3, 5, 7, and 8, then the complement, and complement, whenever you're talking about complement, you always write it as, if you're writing the complement of set A, it would be A, almost looks like A prime, but it looks like it's actually a little apostrophe. So it's A, the complement would be A with a little apostrophe there. Complement of set A is, and then now what we're going to do is just write down, here's all the elements in this universe. Set A has used these, so the complement is going to be all the elements in the universe that weren't covered in set A. So we would need to write down 2, 4, 6, right? Just 2, 4, and 6. So 2, 4, and 6 would be the complement of set A. And again, we write that A with our little apostrophe there. All right? So that's what complementary sets are. All right, so let's take a look at relationships of complementary sets. Okay, so relationship of complementary sets. Let's take the sets that we just used up here in this previous example, universal set, set A, and the complement of set A. All right, so using that, if you take set A and you find the intersection of set A with the complement of set A, so wherever these, basically whatever they're asking for, whatever is in common with these two sets. Again, the whole idea of the complement of set A is that it's all the parts of the universal set that weren't covered in A. So whenever you get this, you should always end up with the empty set, because the complement of A is basically covering everything that A didn't already get. So nothing in the complement of set A should be in set A, and also vice versa. Nothing in set A should be in the complement of set A. So that should always be the empty set. Okay? If you take the union of set A and the complement of set A, it's all of those together. So that would be 1, 3, 5, 7, 8 plus 2, 4, and 6. That's always going to be whatever the universal set is, because that's how we find the complement of set A, is finding all of the rest of these that weren't used. So that would always be the universal set. Okay? And then for this one here, the number of elements in the complement of set A, if you think about it here, we have 3 here, and there's 1, 2, 3, 4, 5, 6, 7, 8 here, and there's 5 here. So this 3, you find the number of elements in the complement by taking the universal set and subtracting all the elements that you used in set A, and that will leave you with the number of elements that you have in the complement of A. So basically it's just the number in the universal set minus the number in set A should always give you the number of elements in the universal set. Alright? Okay, let's take a look at some examples from our book.
Alright, so example 3 from page 70 gives us this here. Here's our universal set, x such that x is an element of the integers where x is between -5 and 5, including -5 and 5. Set A is a set where x such that x is an element of integers where x is between 1 and 4, including 1 and 4. And then set B are all the x's such that x is an element, or x is an integer where x is between -3 and 2, including -3, but not 2. Okay, so from that we want to list the elements of all these sets, and it goes A through H in your book, and then I put I on there just for good measure. Now if you'll notice in here, they don't actually ask for the universal set, but I think that's going to help us out a lot to know what's in the universal set, so I'm just going to include that up here. So I'm going to make our universal set is, and as you can tell, I'm a math teacher and I've been trying to write these brackets here for a long time, and they don't always work out beautifully like that. Just try your darndest. I'm not gonna be too nitpicky on you with how beautiful your brackets are, but just just give it a shot. So universal set is all the integers between and including -5 to 5. So that's just going to be -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. Okay, so that's our universal set. Okay, which is kind of handy. All right, so now from that, let's start listing off all these other elements. All the elements in set A. So here's set A. It's integers between and including 1 to 4. So that set is just going to be 1, 2, 3, and 4. Okay? And again, you can tell brackets not beautiful, but it's good enough. All right. B are all the elements in set B. So here's set B, and those are integers between, but not including, between -3 and 2, including -3 but not 2. So again, since it doesn't have the equal sign, it doesn't include 2, so we start with -3, oops, -2, -1, 0, 1, and again it doesn't go up and include 2 since it doesn't have the equal sign, so we just end at 1. Alright, so that's all the elements in set B. So A prime, we usually call that A prime, but that's just the complement of set A, and that's going to be everything in the universal set. That's why I see it's handy to have the universal set written down there. All the pieces of the universal set that aren't already included in set A. So that would be -5 all the way up to 0, right? And then also 5. So -5, -4, -3, -2, -1, 0, and 5 would be the complement of set A. Alright, complement of set B are all the elements in B, well, all the elements in the universal set that aren't in set B. Alright, so I'm going to start with, we got -5 and -4, and then it picks up -3, so we got -5, -4, it covers -3 up to 1, so then we need to include 2, 3, 4, and 5. Okay. Now we can use all this information here to figure out the rest of these problems.
So A intersect B, right? So that's all the pieces that are in A, has to be in both A and B. So set A is 1, 2, 3, 4, and then set B is 0, sorry, -3, -2, -1, 0, and 1. The only two that these have in common are just 1. Okay, so our answer there is just the set that includes 1. Okay. For F, we have A union B, so it's everything that's in A and B. Any element that appears in either one of those will be included in this here. So A is 1, 2, 3, 4, and then B is -3, 2, 1, -3, -2, -1, 0, and 1. So let's start with -3, -2, -1, 0, 1. That covers all of B, and then we already covered the 1, so we need 2, 3, and 4. Okay, oops. See, that's a terrible bracket. Not a lot better, but a little. Excuse me. So that's A union B. Okay, that's everything in A and B put together. Now, everything that's in the intersection of A prime and B. So what do A prime and B have in common? So here's A prime and here's B. So what do these have in common? They have, let's see if we can highlight this to make this a little easier. So they both have -3, they both have -2, they both have -1, they both have 0. So it's those 4 there. Okay? So we have -3, -2, -1, and 0. Alright, now the union of A prime and B prime, or the complement of A and the complement of B. So what do these, if it ends up in either one of these sets, we list it out. So we've got -5 all the way up to 0. So let's write those down. -5, -4, -3, -2, -1, 0. And then we also have 2, 3, 4, and 5. 2, 3, 4, and 5. Right? So it's basically everything except for 1. Right? 1 is the only number that's missing in there. And then our last one, what's the intersection of A prime and A? So what do A prime and A have in common? And if you'll remember from the notes before that, it shouldn't be anything, right? Look, 1, 2, 3, 4, and then A prime, again, is everything that's in the universal set that's not already included in there. So that is just going to be the empty set. Okay, so you can write it like that, or if you really want to challenge yourself, you can write empty brackets. That's also another way of saying the empty set. All right. Let's take a look at one more example. It's example 4 from page 71.
Alright, so example 4 from page 71 is if the universal set is the positive integers, and then set P is the multiples of 4 less than 50, and set Q is multiples of 6 less than 50. We're going to list P and Q, find P intersect Q, find P union Q, and then D is the hard one, verify that the number of elements of P union Q equals the number of elements in P plus the number of elements in Q minus the number of elements in P and Q. Alright, so let's start with A. Okay, so we're going to list the elements in P and Q. So P is going to be, and you're always going to want to put this in your set builder notation with your brackets here. So P is going to be, again, all the multiples of 4 that are less than 50. So let's just start with 4 and go up to
but not include 50. 4, 8, 12, 16, 20, 24, 28, 32, not 37, 36, 40, 44, and 48. Alright, so that's all the elements in P. Alright, elements in Q are all the multiples of 6 that are less than 50. So 6, 12, 18, 24, 30, 36, 42, and 48. Right? Alright, I hope that's right. So, that's all of our elements in P, all of our elements in Q. Okay? So for part B, we're going to find the intersection of P and Q. Right? So P intersect Q is the set. So what do these things all have in common? So let's figure this out. Okay, they both have a 12. They both have 24. They both have 36. And they both have 48. So those are all the ones that are in the intersection of P and Q. Right? So let's write those down. We've got 12, 24, that looks like 17. 12, 24, 36, and 48. Okay? So for C, find P union Q. So all of them that are included in P and Q. So P union Q. Again, it's always nice to try to write them all in numerical order. So let's see what we can come up with. Right? So we got 4, 6, 8, 12, 16, 18, 20, 24. Let's see, that leaves us up here 28, 30, 32, 36, 42, 44, and 48. Alright, so that's all of them. That's fun. Alright, and then let's do part D here. We're going to need some space. So let's get rid of this stuff here. Alright, so let's do D. So verify that the number of elements in P union Q, which was C, which we just erased. I'm going to go back and unerase that because we're going to need all that stuff, aren't we? So that was this stuff here. Let's just do it over here on the side, I guess. So, number of elements in P union Q. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Alright, so let's do this. N of P, U, Q should equal number of P plus number in Q minus number in P union, intersect Q. Ugh, didn't quite fit that all in, but you get the idea. So, we just figured out that the number of elements in PUQ is 15. P union Q, that's this one here. Number of elements in P, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, equals 12. And then the number in Q, 1, 2, 3, 4, 5, 6, 7, 8, minus P intersect Q, so that's 1, 2, 3, 4.
right? And so 15 equals 20, what did I just count? Because that does not work out. Let's see, obviously miscounted some. Let's double check here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Did I miss one? I think I missed one. Let's cross them off as we go. Okay, so we got 4, 6, 8, 12, 16, 18, 20, 24, 30, 28, 32, 36, 40, I forgot 40. Okay, so let's do 40 in there. Alright, so then now that turns this into from 15 into 16. Now we're talking business. 20 minus 4, because 12 and 8 is 20 minus 4, so we get 16 equals 16. So then we're good. So there's a lesson for you. It pays to take time to make sure you do it right. One other quick thing, just to kind of take a quick look at this, just so you're not plugging in numbers so you can actually understand what we're doing. If you think about it, the number of elements in this here, which is 16, should be the number of elements P and the number of elements Q, but you'd have to subtract off the ones that are in both P and Q, because if you think about it, we count the 12 twice, the 24 twice, the 36 twice, and the 48 twice. That's why you subtract off that P intersect Q. Okay? That's all there's for this section here. If you have any questions, feel free to ask. Thanks.